Okay, geometry. Continuing in chapter 11 here at the beginning, where we're working on area here, the measurement of how much area a two-dimensional figure takes up. We're going to move on now into circles and get into something called sectors. But before we do that, we're going to take a little bit of time here just to make sure that we understand some basic vocabulary about circles. And then we're going to talk a little bit more about circumference and arc length. So if you feel you've got a firm handle on these things already, you might want to skip to the second video here. But the first one is just going to make sure that we know what we're talking about here with circles. So obviously here, every kindergartner can recognize a circle for you. So I've got a diagram here on the right with a bunch of extra stuff drawn in there as well. And we're going to run through a list of terms here. So the first thing I thought we would do is define what a circle actually is. And the definition of a circle here is going to be the set of all points here. Sometimes in geometry we use the word locus instead of the word set, but we're going to go with that. The set of all points that are equidistant. So that's a word we use a lot in geometry here. Equidistant from a given point. And that given point that we have is called the center of our circle. So every one of you could look at this there, and if I would ask you to tell me where the center is, that's going to be point A. So we would name this circle right here using the proper terms of geometry here. We would just name it Circle A with that little circle symbol out in front. A circle is named by its center, and that's what point A is for there. Okay, so moving on down, a couple more things that we want to define as we go through here. A radius then is going to be a segment, let's jot this one down, a segment that goes from the center, so it's got to start in the middle of the circle, from the center to, and then we would say any point on the circle. And because a circle is made up of an infinite number of points, that means that every circle has an infinite number of radii. In this diagram, if I were to ask you guys to name a radius for me, a segment that goes from the center to a point on the circle, pretty much everybody is going to tell me that line segment AB is the radius here. And that is true. There actually are two more as well, though. Line segment AE is a radius, and so is line segment AC. So there are actually three radii drawn within this circle here. Okay, next word, a chord right here is going to be a line segment, and all we need to say about a chord here is that it's going to have we're going to say both endpoints of your line segment. Both endpoints are going to be on the circle. So a radius is not a chord because in all three of these radii, A is one of their endpoints, and A isn't on the circle. A is the center of the circle. So there are two chords that we have drawn in this figure here, guys. Line segment DF would be one of them because both points D and F are located on the circle, and line segment EC is a chord here as well. Again, we could draw more, but that's all that are drawn in this figure right now. Okay, moving right along here, guys, I want to define diameter and central angle, but I think it might help us if I move this diagram down a little bit so that we could actually see it right here. Okay, a diameter, guys, is very simply going to be a chord. So I'm going to stop right there for just a second. The definition we just wrote down for chord right here, a segment with both endpoints on the circle, applies. But a diameter has one special thing. A diameter is a chord that passes through, or you could say that contains, that passes through the center of the circle. Okay, and with that definition in mind, there's only one diameter that was drawn here, and that was line segment EC. It is a chord because both of its endpoints are located on the circle, but it passes directly through the center, point A. So DF and EC are both chords, but only EC is a diameter, and that one right there is the longest chord in the circle. Might be helpful to jot that down as well. So the longest chord in the circle is a diameter. And the last one, central angle, I'm going to spare you guys the formal definition right here, and we'll just go ahead and write an example. A central angle, as I'm hoping you can tell, is an angle whose vertex is located at the center. In fact, let me just jot that down real quick. So vertex at the center. Okay, and then the two sides of your angle are going to be radii. That's the way we spell the plural of radius. So the central angle, the only one that I have drawn in here, would be the angle that starts at B, goes to A, and then ends at C right here. So angle BAC is the only central angle that we have drawn here in this figure. Now, there are more terms that we're going to need to know a little bit later on in the year here about circles, but that's probably a good start for today, and I think that's going to get us everything we need here for this section. So now that we know a little bit about what a circle is and what some of the parts of it are, let's get into some new information right here. So again, you might have this information down already, but just in case you don't, we want to define the word circumference. And the definition of circumference is the distance around a circle. Now I'm going to write a word here, and then I'm going to cross it out as soon as I do. The word that's really, really similar to circumference is perimeter. Perimeter is defined as the distance around a polygon, but there's no such thing as perimeter of a circle simply because a circle isn't a polygon. But it's totally fine if in your head you think that circumference and perimeter really mean the same thing. They both mean the distance around an object, but perimeter is polygons and circumference is circles. And the formula for circumference is right here in this first box, guys. Circumference is equal to 2 times pi times r. And r represents the radius that we talked about back over here on the first slide right here, a segment from the center to any point that's located on the circle. Well, that was weird. Why did that happen? All right, I lost my little box right there. I'll slide that back. No, apparently I can't. There we go. Okay, there's also an alternate version of the formula for circumference right here. Circumference is also equal to pi multiplied by d, d being your diameter. And the reason for that, guys, you may have figured this out already, is that if a radius of a circle goes like that, and that's r, if I were to just extend this in the other direction, I just drew a second radius, and together that makes a diameter right there. So what I hope you can tell there is 2 times your radius is going to equal a diameter. So if I replace the 2 and the r, there's your 2r with a d, that's where you get this alternate formula here. And I remember when I was a kid, this was the formula that I seemed to know better. Circumference is pi times d, but this is the one we tend to use more often today. Now, the reason for this, I don't want to spend too long talking about this. Most people can tell me that pi is a number that is approximately equal to, but not exactly, 3.14. Now, really, it goes further than that, as most of you guys know. Pi is an irrational number, which means that its decimal approximation isn't perfect, and it goes on forever, and it never ends. If I were to go to my calculator and just say, hey, calculator, what is pi? On the right here, you'll see that it says 3.141592654. That is 9 decimal places. But pi actually goes on much, much, much further than that. So it's worth a quick discussion now that we're in geometry. Where did pi come from, and why didn't they make it something nice like 3 instead of this ugly number? Well, right there, just asking that question shows that we don't really understand what it means. Ancient mathematicians realized that there was a relationship between pi and then the other measurements in a circle. So what they did is they drew, let's say, a relatively small circle right over here. Okay, and they measured the diameter of that small circle, and then they measured the distance around it. And when they took the circumference and divided it by the diameter, they came up with this ugly number of 3.14159, blah, blah, blah. Then they did the exact same thing with a slightly bigger circle. They said, all right, we're going to measure the circumference and the diameter of this circle. But what they noticed is when they divided the new circumference by the new diameter, they got the exact same ugly number, ugly ratio right there. And then maybe just for fun, they did it one more time with an even bigger circle. All right, this one is going to have a larger diameter, but it's also going to have a larger circumference. And lo and behold, when they divided this circumference by this diameter, they got the exact same ratio of 3.14159, so on and so forth. So pi was not a choice that any human being made. It was based on observation and then kind of extrapolation from that. And after they did this a few times, they said, you know what, this is silly. It appears that no matter what size circle that I measure here or draw, my ratio of circumference divided by diameter is always going to be this ugly number right here. So you know what? Instead of writing down this nasty number, let's just assign a symbol to it, guys, and they called that the Greek letter pi, which is what the Greeks used for the letter that we now call P. So that's where this concept right here that pi is roughly 3.14 came from. It was circumference divided by diameter, which actually gets you to this formula right over here if you were to multiply both sides by d. So again, pi was not something that anybody chose. It's just the way it works out. When you divide a circle's circumference by its diameter, you always get this ugly number. So that being said, we're just kind of using that idea, that identity in a different direction, because very often we know the radius of our circle and we want to find the circumference. So let's see this in action right here, guys. Let's find the circumference of this circle right here. And sometimes it'll be given to you with text where you'll just have to read it. Sometimes it's given to you as a diagram. Here you've got a diagram, and we've got a radius here of 23 inches. So here we go, guys. Three-step process we've been using for a while now. We're trying to find circumference, and that formula is going to be 2 times pi times your radius. Step 2, fill in what we know. We're trying to find the circumference. We don't know it yet, so C is equal to 2 times pi, and you'll notice, guys, there's only one piece of information you need to know about a circle in order to figure out its circumference, and that is its radius, which in this case is 23 inches. And this might be different from what you guys might have been asked to do in middle school. At this level, guys, in high school geometry, we are more interested in exact answers. So I'm going to have you guys multiply this out, but leave your answer in terms of pi. All that means I have to do is multiply 2 times 23, which is going to get me a 46, and we're just going to leave the pi at the end. 46 pi. Inches are the only units we have right here, so that is the answer I'm going to ask you guys to give me here, and I probably should have put this in the directions here, in terms of pi. Or you also could have said an exact answer as opposed to a rounded. Now listen. If we were actually building something in our backyard right here, like a pool, and you wanted a border around it or something like that, it's more useful to you to actually know what that is rounded. So if you wanted to, go to your calculator and type in 46 pi and hit enter. On your multi-views, you'd probably have to hit 46 pi, enter, and it'll probably tell you 46 pi. Then you'd have to hit that double arrow key right above the enter right there. So 144.51 would be the approximate answer here. So C is approximately equal to 144.51 inches. That's not a bad answer either. It's just a question. Did I get that right? I did. It's just a question of what the directions are asking you for and how they want the answer expressed. But on most of the work that I give you at this level, I'm going to ask for the exact answer. So 46 pi would be our circumference there. And then, as is often the case in this chapter, we also do some problems where we flip things around. Now, we are being asked to find the radius of a circle, and the circumference is given to us here at 17 pi. And this is where the three-step method is really helpful, guys. Start with your formula, including the left side. C is equal to 2 pi r. A lot of people just want to write 2 pi r. Step 2, fill in what you know. Our circumference is 17 pi, so that goes over here on the left, and that equals 2 times pi, and we don't know what r is, so we just leave that as an r. And then in step 3, we solve this equation. So here, we're trying to get r by itself. So what's happening to r right now? It is being multiplied by 2 pi, so we're going to divide both sides by 2 pi. Now, I got to warn you guys here, there's a right way and a wrong way to do this in the calculator. Really, what you should see right now is that there's a pi on top and a pi on bottom that cancel each other out completely. Now, by the way, on the right, the 2 and the 2 and the pi, they cancel out. So I'm really just left with 17 over 2. So that's going to get me r equals. And the best way to handle this is to go to the calculator and ask it what's 17 divided by 2, and you're going to get 8.5 for your radius. Everything here was being measured in centimeters, so that's the answer that I'm looking for. Now, I want to warn you guys, though, if you go to the calculator, it's really easy to do this wrong. If you did what I just told you and you canceled out the pi's, you just take 17 divided by 2, and there's your 8.5. But watch what happens if I include the pi's in there, and I'm kind of sloppy with this. 17 pi divided by, oh, this calculator did it. Okay, this calculator went ahead and automatically put it in as a fraction. Okay, and we got the correct answer of 8.5. What some calculators will do is they will actually get you this answer here, 17 pi, and what they'll do then is divided by, and if you don't put parentheses in your multiview, you're going to end up with this answer, which is obviously not what we're looking for. But if you got 83.89, then what you did on your calculator is you typed in 17 pi divided by 2 pi. And it seems like that's what we were doing right here, but the calculator will actually do the 17 pi divided by 2 first and then multiply the result by pi, and that is not what we want. And so, all right, this is not the way we want to type it in. On your multiview, you either should do it as a fraction, 17 pi over 2 pi, or 17 pi divided by, you would need to put the 2 pi in parentheses. So either one of these will get you that right answer of 8.5. You just got to be careful about how you put that in. Okay, last thing we're going to talk about in this video now is something called arc length, and this is just a function of circumference. So an arc is maybe something I could have defined way back over there on page 1, but an arc, in fact, let me just jot this down right here, is simply a portion of a circle. And in this diagram right here, I've got the arc kind of drawn heavily right here. This arc that goes from point J to point I is part of circle H, but not the whole thing right here. And for no reason that I can figure out, the variable S is pretty much used in every geometry book I've ever seen to represent the length of an arc. So when we talk about S, that means arc length. Now I need to introduce something else new to you right here, guys. This goofy symbol right there is a Greek letter, just like pi, but this one is called theta. And we might want to jot that down in our notes. It's like a 0 with a little horizontal line in between. And so the name of that Greek letter is theta, T-H-E-T-A, and that is simply a variable that we use in math and science all the time to represent an unknown angle. So in this setup here, guys, we've got a central angle here, angle JHI, and whatever the measure of that central angle is, we're going to call theta. And that figure right there, that amount of theta, basically tells you how much of the circle we are interested in. Out of a grand total of, well, how many degrees are in a complete circle? Well, that would be 360 degrees. So what we do is we make a fraction here, theta, out of 360. Sometimes, if I look at this diagram, it looks like I've got roughly 1/4 of the circle right here, but it just kind of depends on what the value of theta is. And then we multiply that fraction, theta over 360 times 2 pi r, which is the amount, or the formula here, for circumference. So, arc length is just a part of the circumference of a circle. 2 pi r gives you the distance all the way around the circle, and then theta over 360 is the amount that we want out of that. So theta over 360 multiplied by 2 pi r, or your circumference, is going to tell you the distance along that arc. Okay, so let's do a straightforward problem right here. We've got an arc here that's defined and it's labeled S, and again, that's the variable we almost always use for arc length in this circle right here. So we just learned a formula, guys. S for arc length is equal to theta over 360 multiplied by our entire circumference, which is 2 pi r. Step 2, fill in what you know. We're trying to find S, so I'm not supposed to know that now. And that equals, okay, theta over 360. Theta is the measure of your central angle here, which in this case is going to be 60 degrees, out of a total of 360. And we multiply that by 2 times pi times the radius of this circle, which is given to us right there, which is 9 inches. Now, if I were you guys, I would go directly to my calculator and type all of this in. I just want to make the point right here that 60 over 360 works out really, really nicely, guys. If you divide a 60 out of both of those, that fraction becomes 1/6. So this is like taking a pizza and cutting it up into 6 slices. And that's what we have right over here is 1/6 of this entire pizza. Okay, so that's what's going on right here. So if I wanted to do this slowly, I'd probably say, okay, that fraction becomes 1/6, and my circumference, 2 times pi times 9, is going to be 18 pi inches. And then 1/6 of 18 is going to give me 3 pi inches for the length of that arc. But again, if I were you, I'd probably go to my calculator and type all of this in one step, minus the inches right there, and that should give you the answer we're looking for of 3 pi. Now, by the way, you'll notice we know that pi is 3.14159, blah, 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 so pi is roughly 3. So the value of 3 pi, 3 times 3, would be somewhere in the neighborhood of 9. That means that this arc right over here that I'm hitting in red is about 9 inches long, which should be roughly the same length as this piece right over here. Well, this kind of shape that I have there in red almost kind of looks like the 3 sides could all be roughly the same length right there. So I think that answer makes a little bit of sense. Last problem on this video right here, guys. Find the diameter. We're looking for D now of a circle with a central angle of 120 degrees and an arc length of 10 pi centimeters. Okay, so they gave me arc length, then I'm going to begin with the formula for arc length. S is equal to theta over 360 times 2 pi r. Okay, there are 2 variables in this formula, guys. S for arc length and r for radius. And I was given the arc length to be 10 pi. So in step 2, I put a 10 pi in right there for S. Now, I lied. I'm sorry, guys. There's actually a 3rd variable right there I missed. Theta is a variable as well, and that was given to us also. 120 goes in for theta over 360 times 2. Remember that pi is not a variable. It's a mathematical constant, and we don't know what r is, so I'm going to leave that one blank. Okay, so now we've got to work here in step 3 on trying to solve for this r right here. So how are we going to do that? I'm going to leave the left side alone right now and just make it 10 pi, and I'm going to clean up the right side a little bit. 120 over 360, grab your calculator if you need to, but that becomes 1/3. And when I multiply 1/3 times 2 pi, I'm going to get 2/3 pi with an r right there. Now, trying to get the r by itself, what I'm going to do now, guys, to get rid of 2/3, rather than dividing by a fraction, I'm going to multiply by its reciprocal, which is 3 over 2. And I'm going to do that exact same thing on the right side as well. Now, that will make this 2 cancel with that 2, and this 3 cancel with this 3, but I still have the pi in the way. So the other thing I'm going to do is put a factor of pi down here in the denominator with the 2, and I have to do the same thing right there, because now this pi on the top cancels with this pi on the bottom. So my right side now is just down to r. That's what I wanted. And on the left side, another cool thing happens there. Pi on the top, pi on the bottom cancel each other out. So you can grab your calculator now and ask it, what's 3/2 times 10? We're going to get 15 there on the left-hand side, and that is the value for r. Only problem? The question didn't ask for radius. It asked for diameter. But hopefully we know this, guys. A diameter is always equal to 2 times your radius. So for us, diameter is going to be 2 times a radius of 15, and we're going to get 30 here for our diameter. Units are being measured in centimeters, so 30 centimeters is the length of our diameter. So you always have to read your directions carefully and make sure that you're answering the question that you were asked, which is a big skill we've been practicing all year in geometry. All right, guys, I'm going to cut this video off right here. We're going to come back on the next one and start talking about area of a circle. But for now, hopefully that gives you a pretty good understanding of some basic vocab of a circle and how to find circumference and arc length.